The universe is expanding since 1929, and we now know that we are made of chemical elements forged in the centers of stars, discovery from 1957. The sky isn't just pretty to look at, it's a window into the insanely powerful universe we live in. There's so much happening out there, and we on Earth are usually oblivious to what's truly going on. Why are we here? Why do we have stars and galaxies? It could have been something else entirely. Even though these cosmic events will eventually affect us, we often don't pay attention until things become too serious, and that might be happening again. Throughout history, Betelgeuse has been one of the brightest stars in the sky, but now it has begun violently vibrating, and something terrifying is happening. Join us as we bring you all the details about what's going on with Betelgeuse and how it might change our future along with its own. Betelgeuse isn't just an ordinary star, it never has been. It's one of the largest stars ever discovered, so massive that it makes our Sun look small in comparison. With a mass roughly 20 times that of our Sun, Betelgeuse bears the undeniable mark of a supergiant star, and that's exactly what it is. However, perception can be deceiving. From our vantage point, Betelgeuse might seem like just another distant star, but in reality, it holds a status far more profound. Located more than 640 light-years away from Earth, this distance may seem inconsequential at first glance, but in cosmic terms, it's monumental. Even if we could travel at the speed of light, it would still take us over 640 years to reach Betelgeuse. In more realistic terms, using current technology, it would take over 12 million years to make the connection, a period far longer than the entire span of human civilization on Earth. This perspective highlights just how powerful Betelgeuse really is, and now, it's been vibrating violently. We tend to think of stars as calm, steady objects, simply existing in space regardless of their size, but Betelgeuse proves that this isn't true. Scientists are puzzled by its recent vibrations. You see, Betelgeuse has never been completely still, it has always been known as a pulsating red supergiant, constantly changing. When the star expands, it looks brighter, and when it contracts, it appears dimmer. These fluctuations in brightness take place over extended periods, ranging from tens to hundreds of days. What's even more interesting is that Betelgeuse showcases a wide range of brightness, spanning from approximately plus 0.5 to a more intense magnitude of 0, a significant difference when it comes to stars. These shifts in brightness happen in recurring patterns, with the shortest cycle lasting about 185 days and the longest extending to around 2,335 days. Occasionally, these fluctuations are more periodic and follow a recognizable pattern, something astronomers refer to as V-band magnitude. In February 2021, Betelgeuse registered one of its lowest V-band magnitudes in recent times, measuring at plus 1.614. While still relatively bright, this marked a departure from its usual radiance. Betelgeuse's significance isn't only defined by its changes in brightness. Its distinct reddish hue stems from a cooler surface temperature of around 3,500 Kelvin, notably cooler than our Sun's 5,500 Kelvin. That may seem strange, as Betelgeuse is far larger than the Sun, yet appears dimmer. The cooler temperature results in reduced energy emission per unit of surface area, which makes Betelgeuse seem dim despite its massive size. Although it's been a relatively stable star for much of its life, recent violent changes suggest something bigger is happening. One of the prevailing theories is that Betelgeuse's helium shell is burning. As Betelgeuse evolves through its stellar life cycle, it gradually exhausts the hydrogen in its core, converting it into helium through nuclear fusion. As hydrogen fusion slows, the star's outer layers expand, marking its transition into the red giant phase. During this stage, helium accumulates in a shell surrounding the hydrogen-depleted core, initiating secondary nuclear fusion known as helium shell burning. This process creates heavier elements like carbon and oxygen, releasing energy that counters the gravitational force trying to collapse the star. However, helium shell burning isn't as stable as hydrogen fusion in the core. It can lead to periodic energy buildups and releases, which could explain Betelgeuse's recent pulsations. These fluctuations result in the outer layers expanding and contracting, manifesting as changes in brightness, similar to a star's rhythmic heartbeat. Astronomers use various techniques to study pulsating stars like Betelgeuse, with photometry and spectroscopy being key methods. Photometry monitors the star's brightness over time, revealing its dynamic behavior, while spectroscopy analyzes the light emitted across different wavelengths, providing insights into the star's temperature, composition, and motion. Together, these techniques allow astronomers to create a comprehensive narrative of the star's pulsation behavior. But there's more to it. Deep within stars like Betelgeuse, a process known as stellar convection occurs, responsible for transferring energy from the star's core to its surface. This convection creates dynamic flows of matter, transporting energy upward. As hot material rises to the surface, it radiates light, making the star appear brighter. But fluctuations in this convection process can cause changes in brightness, resulting in pulsations. Additionally, Betelgeuse could be part of a binary star system, and material transfer between stars might be contributing to its pulsations. In such systems, gravitational attraction can pull material from one star to another, altering the recipient star's mass and triggering pulsations as the star adjusts to its new equilibrium. Still, there's another explanation that's been lurking in the background. Betelgeuse might be nearing the end of its life and could soon go supernova. Betelgeuse is in the final stages of its life cycle, where gravity and nuclear fusion reactions are locked in a struggle for balance. As it depletes its nuclear fuel, the balance shifts, and the star's core begins to contract, raising the temperature and triggering more nuclear fusion. Eventually, Betelgeuse will fuse heavier elements like carbon, leading to the formation of an iron core. However, iron fusion consumes more energy than it produces, causing the core to collapse under gravity, leading to a supernova explosion. This would violently eject the star's outer layers, creating a brilliant burst of light that could be visible from Earth. If Betelgeuse were closer to us, the gamma-ray bursts from such an explosion could have catastrophic effects, depleting the Earth's ozone layer and exposing life to harmful UV radiation. The effects of a nearby supernova would extend beyond just a light show. It could disrupt our technological infrastructure, generate electromagnetic pulses that damage power grids, and even alter weather patterns and atmospheric chemistry, potentially affecting food security and ecosystems. In conclusion, Betelgeuse is undergoing significant changes, and while we don't know exactly what's causing its pulsations, the possibility of a supernova looms large. If that happens, it could be one of the most spectacular and dangerous events to ever unfold in our skies.